It's very useful for finding zeros of your function. So the intermediate value theorem, it says use the intermediate value theorem to show that the following polynomials have a zero on the designated interval. So a zero, remember, is when f of x is equal to 0. It's your x value. So I'm going to say the x value when f of x is equal to 0. So the x value when f of x is equal to 0, those are your zeros of your function. So we're going to look on this interval 0, 1, and we're going to have this function. So f of x is equal to x cubed minus 3x plus 1, and we're going to set it equal to 0. We're going to see if there are any x values. We're going to find the x values. Are there any x values when f of x is equal to 0 on this interval? So on this interval, so between 0 and 1. So what we're going to do is we're kind of, first we need to get these endpoints. So we need to get these endpoints right here so that we can, so we're going to look at these endpoints. We're going to look at these endpoints. Our y value is 0. So we're going to try to see if these two endpoints, if their y values are a little bit bigger than 0, a little bit smaller than 0, then we know that as it goes from the right and to the left, that it has to pass by 0. So if one of them, I'm going to make a small note. So I'm not going to show you guys this yet. So for instance, to find the solution, in order to pass this x value, so if we're going from 0 to 1, so if we're going from 0 to 1, we're either going to have to have an x value right here that goes down and crosses at 0 somewhere over here. So it's either going to have to go from a positive value to some negative value, or it's going to have to go from some negative value to some positive value in order for it to cross the x-axis, the point where f of x is equal to 0. So we're going to be comparing our y values at the endpoints. If it goes from positive to negative, then we know that if our y values go from positive to negative, then we know that it has to pass y equals 0 over here. Same thing over here. If it goes from negative to positive, we know that it has to pass through 0 on its way through. So let's look at this. So let's check our endpoints. So when we plug in this endpoint at x equals 0, we get f of 0, which is 0 cubed minus 3 times 0 plus 1, which is 0 plus 0 plus 1, which is plus 1. So this is positive. So right now, I'm going to get another Post-it. So right now, what we have is we have at 0, we have some positive number up here. So that's a 0. That's a really awful 0. I'm sorry. At 0, I'm going to draw a really pretty 0. So this right here, that's 0. So at 0, we have some value right here. So if it's positive, if our next value is also positive, say our next value is 0.1, we cannot guarantee that we cross through the x-axis. So in order for it to cross this x-axis, in order for there to be a 0, this number has to be somewhere down here for it to cross. So hopefully the next value, our other endpoint, is negative so that we can say that it needs to cross the x-axis sometime. So let's look at our other endpoint. So at x is equal to 1. So at x is equal to 1, when we plug it in, 1 cubed minus 3 plus 1, that's negative 2 plus 1, which is negative 1, which is negative. So if we were to draw this, so I sketched this. I sketched the point 0, 1. So 0, 1 is up here. 1, negative 1, which is down here. And at first I drew a straight line. So it could be a straight line. This is, I think, the most kind of straightforward way of thinking about, it's the most basic way of thinking about a continuous function, just a straight line that connects the two dots. It doesn't necessarily have to be a straight line though, it just has to be continuous. So I also wrote in purple, it could look something like this. It could go up and down and up and down. It could actually have 3 zeros right here. 1, 2, 3, instead of just the one that you had with the straight line. You don't know exactly what it looks like. The intermediate value doesn't tell you exactly what it looks like. It just says that there's at least one time when it does cross through there. So because of this, because our x values go from positive to negative, or sorry, not x values, the y values go from positive to negative, then you can say that the y value is 0 somewhere in between this interval. So I'll write that out in words. Because the y values go from positive to negative, and because f of x is continuous, we can say that there must be some x value on the interval where y equals 0. So y must equal to 0 on the interval 0, 1 by the intermediate value theorem. I'm going to, a lot of times you just abbreviate intermediate value theorem to IVT. It's kind of a long theorem to write out, intermediate value theorem. So IVT is just perfectly fine. Math people like acronyms, I think, because we don't really like to spell. All right, so let's look at another one. So if we have something like this, if we're looking at x squared is equal to the square root of x plus 1 on the interval 1 to 2. We want to see if there's any zeros here. So first of all, we need to set the equation equal to 0 to see if there's any zero if the function, if f of x is equal to 0 anywhere. So let's set this equal to 0. So I'm going to say this is x squared minus the square root of x plus 1 is equal to 0. So this is going to be our function right here. So this is going to be our f of x. And so we're letting, so finding the zeros, again, we're finding the x values that make our f of x equal to 0. And we're going to check our interval again. So we're going to check our interval. So let's see what f of x looks like at 1. Oops. So f of 1. F of 1 is 1 squared minus the square root of 1 plus 1, which is going to be 1 minus the square root of 2. 1 minus the square root of 2. So square root of 2 is between 1 and 2. So it's between 1 and 2. So this is going to be some negative value. So this is going to be some negative value. And this is because this is approximately, here, I will give you an actual approximation. All right, so the approximation for the square root of 2 is 1.4142. So yes, round to 4 decimal places when possible. So it's a negative value. So this one's negative. 1 minus 1.14 is negative. Let's look at f of 2. Let's hope that it's positive. Remember, if we go from a negative to a positive, it has to cross that x-axis, that the point where y is equal to 0. So let's see, at 2, 2 squared minus the square root of 2 plus 2, which is equal to 4 minus the square root of, plus 1, square root of 3. This is going to be 4 minus, this is like 1 point something as well. It's between 1 and 2. So this one's going to be positive. So if you want me to give you the approximation, I'll give it to you. I have my calculator out. It's about 1.7. So 4 minus about 1 point, here, let me practice approximating to 4 decimals. 1.7321. So this one's positive. So it goes from negative to positive. And again, I will sketch a graph for you. So at 1, our value, it's about, you can say about 4.1. This is 1, 2. And then at 2, our decimal, it's probably about, oh wait, oops, negative. Sorry. Don't use that one. That one's bad. Okay, negative, about 1/2, about negative 1/2. This one's positive, about 2.3, so about positive 2.3, so it goes up here. So on this interval, 1 to 2, here's our 2 endpoints. If we were to connect them, so this is continuous, it is continuous. This is, the square root function is continuous for all positive values in the discriminant underneath the square root. So they're all positive. It's going to be positive. 1 plus 1 is 1. 2 plus 1 is 3. So these are all positive values. So they're all defined here. These are all defined. So it is continuous. So it is continuous on here. So therefore, it crosses at least once. So by IVT, so we say f of x is continuous. Is continuous. We have f of 1 is, so f of 1 is less than or equal to f of, here, no, I'm going to have to write that. I'm going to say, and the function goes from positive to negative. The function goes from positive to negative, goes from positive to negative. Therefore, the function must be equal to 0 at some point in between in the interval. So the function must have a 0 on the interval. The interval by the intermediate value theorem, by IVT. So the function is continuous. The function goes from positive to negative. Those are, again, the y values. The function, I'll say y values, goes from positive to negative on the interval. The function must have a 0 on the interval. I'm going to write on the interval in here. So the function must have a 0 on the interval by the intermediate value theorem. All right, and that's it. Thanks.